Hello, hi everyone. Assalamualaikum. Today we are going to learn about the topic of gradually varied flow in open channel. So there will be two objectives for this topic. First is to present classification system for gradually varied flow profiles. And second, to sketch gradually varied flow profiles in the context of classic flow problems. So we are going to do some exercise at the end of the course. Okay, at the end of this video, I mean. Okay, so first of all, non-uniform flow is the flow that describes gradually varied flow. Okay, so non-uniform flow changes with depth as it moves along the channel. So if you can see in this figure, this is figure 5.1 from textbook. Okay, so we have like two lines here. This is line A and this is line B. So this is Y. Y is the depth of the channel. Okay, so if you see here, okay, this is where the water flow to the right direction. And if you see from here, from this point, we can call it 1, to the second point, there is changes of height or depth of the river. So this is what it means with non-uniform flow. Okay. Okay, it also says here the profile is bounded by lines A and B, okay, which are parallel to the channel bottom. Okay. Okay, so now this is water surface profile. Okay, water surface profile is the shape of the water surface, which means how depth changes with distance over a segment of stream reach. Okay, so this is normal Y of the channel, and this is the critical depth of the channel. Okay, so if the normal depth of the channel is more than the critical depth, it means the reach is mile. So reach is also known as where the water flows. Okay. Okay. So if normal depth is more than critical depth, then it's called mile reach. So the symbol is M. So this is also related to the slope of the friction and slope of the bottom. Okay, so in this case, friction slope is more than bottom slope. Okay, so the second case is when the normal depth is less than critical depth. So this is what we call as steep reach. Okay, the symbol is S. And for steep reach, the friction slope is less than the bottom slope. Okay, but when Y normal depth is equals to critical depth, then we call this as critical. Okay, so we have another one. This is horizontal reach. Horizontal reach happens when the slope is equals to 0. So there is no slope basically. Okay, but finally for adverse reach, okay, this adverse reach means the channel is sloping uphill, so it go upward like this. Instead of for this one it goes down like this, but for adverse reach it goes up. So because it goes up, it lacks gravity to support flow, thus only occur over short distance. Okay, so this is an example of mile reach. Okay, so for mile reach, like I said to you in the previous slide, we have these two bounded lines. Yeah, so this is our flow. Okay, so this is the lines. Okay, so what it means? So this is so if line A is equals to normal depth and line B is equals to critical depth, so here you can see that normal depth is more than critical depth. So this is under the category of mild ridge. Okay, but in the second scenario where you have critical depth is more than the normal depth, then we call this steep ridge. Okay. Okay, so this is what you have to really understand. It's not difficult because it only involves the depth and slope. Okay, depth. When you talk about the profile, so you actually talk about the depth of the channel, and then with the depth of the channel, so you have critical depth and you have normal depth. Okay, and then you have the slope of the channel. Okay, and then later we will talk about energy. Okay, the slope is normally fixed for any problem, and this but normally if you want to solve any problem, it's almost related to depth and energy, and this will relates with the profile of the channel. Okay. Okay, as I told you just now, profile taxonomy, there are 5 different types of taxonomy, either mild, steep, critical, horizontal, and adverse ridges. Okay, in figure 5 in the textbook, the figure presents the complete taxonomy of flow profile for all these types of ridges. Okay. It is important to understand that the profiles provided are an exhaustive set, which means no other profiles are possible. Okay, so in the figure you can see another example of mild ridge. So in this mild ridge, there is also, the flow can go here, or it can be somewhere here, or it can be somewhere here. So that's why we have this 1, 2, 3 types of mild ridge. Okay, and it is the same for steep ridge. There is 3 different types of steep ridge, 1, 2, 3, and we will see how this looks like.